So a third workflow for creating Overscan involves adjustment to the aperture of the projection camera. In my investigations, I kind of suggest that this is possibly the quickest and the simplest of the three methods, and in this short video I'm going to demonstrate how exactly to do that in Nuke. So you can see that I've got a script open already. This is basically the script that I've been using as the starting place for most of these Overscan demonstrations. So you can see here that this projection camera it's basically a replica of the projection camera at frame 50 with the animation removed. You can see that the focal length is at 62. Our animation has been taken off, but we've retained the attributes of the shot camera on this particular frame. So if we just get onto our merge node and zoom in on this, just make sure that I'm hooked up to the merge node, and I start to toggle that merge on and off, you can see there's absolutely no difference between the image that I rendered out as the starting place for my matte painting, which is just a still frame from frame 50. There's absolutely no difference between that and the actual 50th frame of the plate, and nor should you expect there to be any difference. Okay, so our adjustments take place here in the projection camera. So you can see I've got a double, and they take place within the optical attributes, and these are the two things that we're interested in, the two attributes, the horizontal aperture and the vertical aperture. What we're going to do is that we're going to increase and generate overscan by increasing the values that are within these input boxes. So obviously by increasing the value we actually generate overscan. So I'm going to use a mathematical operator, so I'm going to multiply the 36 in the horizontal by 1.32, that's an arbitrary number. And then press enter, and you can see that that gives me a value of 47.52. Okay, I'm now going to do the same thing on the vertical aperture, 1.32, and that gives us a vertical aperture of 31.68. So we've raised the aperture and therefore generated some overscan on this particular image. And we can test this now if we start to merge if we start to toggle between the merge. So that's our matte painting, and if we actually disable the matte painting, you can see that this is our plate. Okay, so without the plate you can see it's considerably bigger, and that's the overscan. So what we need to do is we need to bring this back using the reformat node. So I'm just going to bring out a reformat node, and what we have to do with the reformat node, just connect my viewer directly to it, and I'll just turn the merge back on, so we're connected directly to the reformat node. What I have to do here is I have to set the reformat, rather than using an actual format from the list. What I'm actually going to do is I'm going to change this to scale, and I'm going to make sure that I scale it by exactly the same amount as I increase the overscan. So I've changed that to a value of 1.32. Now this still isn't going to work properly because it's set to the reset type of width, so we need to turn that off, and we need to set that back to none for that to work. And now we can see the overscan, so we can see it smearing out on both sides of this, so this is all overscan area. If we look at it in 3D, we can see that that extends right out to the boundaries of the card. Okay, so that effectively represents our overscan area. So it's going, we can see there 1485 by 835 high. So we can see that we've got an aspect ratio there, which is whole integer values, which is essentially the size of the matte painting. That would be the value that I'd be taking into Photoshop. I'd be taking this image into Photoshop, then increasing its canvas size, using these values to be the new canvas, and that would be the starting place for my matte painting, knowing full well that the extra beyond the 1280 by 720, that extra volume there is my real estate for the matte painting. Okay, so now this is done, we can come back to our merge node, get in nice and close, and then start to toggle between the two. And again we can see there's absolutely no difference between the two on there. So we've generated quite a substantial amount of overscan without any rounding errors, and in a very quick and easy fashion. So I'll finish up here. A very simple and quick technique for generating overscan, and I hope that you found that useful. I hope that you'll be able to add it to your repertoire of overscanning methods.